In this video, I'll share with you how to solve a quadratic equation by applying the square root property. Let's revisit the first method for solving by factoring with these two equations, x squared equals 4 and also x squared equals 49. Let's say I don't know anything about the square root property. To solve that equation by the zero product property, I would have to set one side equal to 0 by subtracting 4 to get x squared minus 4 equals 0. And then I would observe that x squared minus 4 is the difference of two squares that factors as x minus 2 times x plus 2. And then I set x minus 2 equal to 0 or x plus 2 is equal to 0 to get x is equal to positive 2 or negative 2. The solution set then is negative 2, comma 2. In a like manner, x squared equals 49, we would subtract 49 from each side. And observe that we have the difference of two squares again that factors as x minus 7 times x plus 7. So setting x minus 7 equal to 0 or x plus 7 equal to 0 gives us the solutions x equals 7 and x equals negative 7. Therefore, the solution set is negative 7, comma 7. So notice the relationship between the solutions and the equation. For x squared equals 4, what would you say about negative 2 and 2? Negative 2 and 2 are the numbers whose square is 4, so they are square roots of 4. What about negative 7 and 7 compared to 49? Correct, those are the numbers whose square is 49, so they are the square roots of 49. So an equation of the form x squared equals k, where k is a real number, has solutions of square root of k and negative square root of k, which we can write in a compact form plus or minus the square root of k. So applying this property, if I saw the equation x squared equals 4, I could just simply say then x has to be plus or minus the square root of 4, which is plus or minus 2. In like fashion, x squared equals 49 would tell me that x has to be plus or minus the square root of 49 or plus or minus 7. So if we can isolate the squared variable, or it can actually be a squared expression to one side equal to a number, we can apply the square root property. So let me show you some of these equations where we can apply this property. X squared equals 36. Well, I have just a squared expression equal to a number. The square root property then says that x has to be plus or minus the square root of 36. So x is plus or minus 6. And we can write that in compact form as plus or minus 6, or separate the solutions negative 6, comma 6. But keep in mind, the squared equation will have two solutions. In part B, I have the equation 5x squared equals 180. So again, I'm seeing that I don't have just a variable x. So I can isolate the x squared by dividing by 5. And this gives me x squared is equal to 36. And so x is equal to plus or minus the square root of 36, or plus or minus 6. And so the solution set is negative 6, comma 6. Part C is x squared plus 81 equals 0. This time I need to isolate x squared by subtracting 81 from each side. So we get x squared is equal to negative 81. Therefore, x is equal to plus or minus the square root of negative 81. Recall, though, that the square root of negative 1 is I. To plus or minus the square root of negative 81 is plus or minus 9i. So we have two complex solutions that are negative 9i and positive 9i. Or we can write them as plus or minus 9i. Part D is 3x squared minus 4 equals 71. To solve this equation, I need to isolate the x squared. I will first add 4 to each side to get 3x squared equals 75. And then we can divide each side by 3. So x squared is equal to 25. Now I have it in the form where I can apply the property, and that states that x will be plus or minus the square root of 25 or plus or minus 5. And again, if you're questioning your solutions, plug them in place of x to see that that gives you a true statement. So our solution set is plus or minus 5. Part E is a quantity x plus 3 squared equals 12. So even though this is not just a single variable, it is something squared equals a number, so I can still apply the property. It's almost like I'm taking the square root of each side, but I have to be careful to say that that gives me that x plus 3 is equal to plus or minus the square root of 12. I can simplify the square root of 12 by finding a perfect square factor of 12, and that's 4, right? 4 times 3. So the square root of 12 simplifies to be the square root of 4, or 2 on the square root of 3. So to solve for x, I can subtract 3. Therefore, x is equal to negative 3 plus or minus 2 on the square root of 3. My two solutions are negative 3 minus 2 on the square root of 3 and negative 3 plus 2 on the square root of 3 if I write them in order from smallest to largest. So these are two irrational solutions. You could use your calculator to figure out what the decimal approximation is of those values if you wanted to. The last example is 2 times 4x minus 5 quantity squared plus 4 equals 22. Again, notice that I have this squared expression, so if I can get that squared expression on the side by itself, I can apply the property. The first thing I want to do is subtract 4 from each side. We get 2 times 4x minus 5 quantity squared is equal to, well, 22 minus 4 is 18. And then to get the squared expression, I'm going to divide each side by 2. This gives us 4x minus 5 quantity squared is equal to 9. So now I can apply the square root property to write this as 4x minus 5 is plus or minus the square root of 9, or 4x minus 5 is equal to plus or minus 3. And so I can separate these into two equations. This tells me that 4x minus 5 is equal to 3, or 4x minus 5 is equal to negative 3. So adding 5, I get 4x equals 8, and divide by 4 to get x is equal to 2. Or if I add 5 to negative 3, I get 4x equals 2. And dividing by 4, 2/4 is 1/2. So the solution set for this equation is the set containing 1/2 and 2.